Hey there. First and foremost, I want to congratulate you on making it to chapter 5, because I know that if you're here, it means that you've finished chapter 4, and it also means you probably spent a pretty significant amount of time on chapter 4, and we're just totally ready to be done with it. But I really hope that by taking that time, you feel that you mastered the technique for solving equations. Maybe you didn't necessarily master it with decimals and fractions and a little more complex stuff like that, but you at least feel that you mastered it with just whole numbers and you'd be able to knock out an equation, and I'm pretty sure you would be able to. So on this chapter, I really like chapter 5 because it's very relevant. It's a lot of stuff that you've already heard, like, miles per gallon, miles per hour, dollars per hour. So it's a lot of rates, which is something that we utilize all the time in real life. And so I feel like it's going to be very relatable. So let's go ahead and start with the objective for this chapter, which is that by the end of this lesson, I hope that you're able to differentiate between a rate, unit rate, and a ratio. So the objective is I will be able to differentiate, which means to tell apart between a rate, unit rate, and ratio. And then the essential question for today is, how do rates help us describe real life problems? How do rates help you describe real life problems? Okay, so we're all going to start, like we always start off with some vocabulary. And so a ratio is a comparison between two quantities using division. So a comparison between two quantities using division, what does that look like? Well, that looks like a fraction. For example, 3 to 4. We say this as 3 to 4, but because we're saying it as a ratio. If we were saying it as a fraction, we would say 3/4. But this is a ratio of 3 to 4, which can also be written as 3:4. Or you might just see it as 3 to 4. You might see it with the actual word 2 in there, but they all represent the same thing. And so you've heard ratios before, I'm sure. 3 to 4 or half a cup to, ratio now we need to recognize doesn't include any units, which is what makes a rate different from a ratio. So a rate is a ratio, so also has numbers being compared using division. But the thing is that a rate has two different units. So that's the key part here. I want you to go ahead and circle that, underline that or something, but they have to have different units is what makes it a rate. So for example, that 3 to 4, we could say $3 every 4 hours, and we would consider that a rate. Or maybe you're familiar more with speeds. So we could say 60 miles every 2 hours, and that's a rate there. So the ratio is 60 to 2. But because we added two different units, we added miles and we added hours, this makes it a rate. And then the last vocabulary word that we're going to introduce here is that a rate with a denominator of 1, so that means that the bottom number is 1, is called a unit rate. So in the rate example where somebody is traveling 60 miles every 2 hours, that's kind of a weird way of saying that. You don't look at your speedometer in the car and say, oh, we're going 60 miles every 2 hours. We usually say it in terms of we're going so much every hour, so just 1 hour. And so we could simplify this 60 miles every 2 hours to 30 miles every 1 hour, and this is considered a unit rate. It still describes the same situation. In 1 hour, you're going to travel 30 miles. And then in 2 hours, you're going to travel 60 miles. So it's still the same car that we're talking about, but the way that we're saying it, one is a rate, while the other is a unit rate. It's in terms of 1 hour. So the bottom number is 1. And that's how we talk about just everything, really, is miles per every 1 gallon, so miles per gallon, or $10 every 1 hour, 1 hour. So you need to be able to differentiate between a rate and a unit rate, and how you know the difference is that the unit rate has a denominator of 1, or it's just in a single unit. So let's put that into our questions is, what makes a rate different from a unit rate? Whoops, sorry. Okay, so now that we've introduced some vocabulary, let's start putting it to work. So example 1, finding ratios and rates. There are 45 males and 60 females in a subway car. So here's my subway car. And there's 45 males and 60 females. The subway car travels 2.5 miles in 5 minutes. So it's traveling at 5 minutes, and in those 5 minutes it traveled 2.5 miles. Okay, now part A asks us to find the ratio of males to females. And a ratio, if we look back at the vocabulary, is a comparison between two quantities using division. But something you might be asking yourselves is what goes on top and what goes on bottom? Does males go on top, females on bottom? How do you know? Regularly, the way we speak it is the same way we write it. So find the ratio of males to females. So you're going to do it in that order. Males over females. And so we have the number of males in the subway car. There's 45 males. And we have the number of females, 60 females. And so my ratio is 45 males for every 60 females. But we have to make sure that we simplify this so it makes a little more sense. So we can simplify both of these by dividing them by 15. Both values divided by 15 simplify to 3 males for every 4 females. So 3 males for every 4 females. And so that what that means is that every time 3 males get on the subway, 4 females follow. And then another 3 males go, 4 females follow after that. And so that's my ratio. And if you're thinking, well, that has different units, it's males and females, why isn't that called a rate? And it's because we're talking about human beings in both sections. Even though it's males to females, it's still considered the same unit. But that would be how we would find the ratio. Pretty straightforward, I hope. Now, finding part B, the speed of the subway car, this is where we're going to get into rates and unit rates. So to find the speed of the subway car, we talk about speed as distance over time. Distance over time. So we talked about speed a little bit in our example, 30 miles every 1 hour. So our distance, 30 miles over the time of 1 hour. And here in this scenario, our distance is 2.5 miles, and the time that it took to travel that 2.5 miles was 5 minutes. And so this would be considered my rate of speed. This would be considered my rate of travel, my rate of speed. But that doesn't really make sense as far as how we talk about speed. We don't talk about, like I said earlier, 60 miles every 2 hours, or we're not going to say 2.5 miles every 5 minutes. We're going to want to turn that into a unit rate. We're going to want to turn it into a unit rate because then that way it'll tell us how many miles is traveling every 1 minute. And so how do I turn 2.5 miles over 5 minutes into a unit rate? That means that my bottom number is going to be just 1 minute. How am I going to do that? Sorry for my crappy writing. Well, what I can do to this fraction is, because the denominator currently is 5, for 5 to get to 5, I can divide that by 5. Let me do that in a different color. I can divide the bottom part by 5 because 5 divided by 5 will equal 1 minute. And then if I divided the bottom half by 5, then that means I need to divide the top half by 5 also. And so I would do 2.5 miles divided by 5. The outside number is already a whole number, so that means we don't need to move any decimal places around. 5 goes into 2 0 times with a remainder of 2. Bring the 5 down, and 5 goes into 25 5 times. And then don't forget to bring up the decimal. And what this tells me is that we are traveling 0.5 or half a mile every minute. And that makes sense because if you travel half a mile every minute for 5 minutes, that would be half a mile plus half a mile, which is 1, plus another half a mile, 1.5, 2, 2.5, which in 5 minutes, which is what our original rate was. So as you can see, they are the same rate, they're still the same speed, but they're spoken of differently. And the one that makes more sense to us, the one that we want, is the unit rate. Is we want to say that the subway car is traveling half a mile every minute. It sounds a little bit more comfortable than saying that the subway car is traveling 2.5 miles every 5 minutes, which is still true, but just doesn't sound the same as having a unit rate. All right, so I'm going to make a separate video for example 2 so that we don't go too long on just one.